Okay, we'll start section 1.2 here, which is called domain and range. And there's some other things in section 1 and 2 that we'll talk about. The first thing is set notation and interval notation. Okay, these are very important types of notation that you're going to see all over the place in the book. Okay, it's how you write down a group of numbers as a solution for a problem. So let's just take a look at some examples here. So when we use set notation, we always start by writing the set of all x such that, okay, is this vertical bar here. The vertical bar is a necessary thing that we must have whenever we write down something in set notation. You must have that, okay? So the way that I'd read this is to say the set of all x such that x is a number that's less than 3. Okay, so that's how I'd write that as a set. How I'd write it as an interval is, so I'm describing all the numbers that are less than 3, right? So I'm heading out towards the negative direction, towards negative infinity. And so I'm going to write negative infinity, comma 3. And I'm going to put parentheses at both ends. In general, you want a parentheses by a number if you're not including the number, and you want a bracket by the number if you are including the number. Okay, so there's a bracket. So because I'm not including 3, but anything that's strictly less than 3, I want a parentheses by 3. Also, another thing with interval notation is that order matters. You always want the smaller quantity first, the bigger quantity second, as you read this from left to right. So, you know, if somebody were to write 3 comma negative infinity, that wouldn't make any sense to anybody, okay? And then on the number line, if we were to graph that, here's the number line. I mark out 3, and then I'm going to put an open circle above 3. In general, you want an open circle if you're not including the number, and you want a closed circle if you are including the number. Okay, so since I'm not including 3, but anything less than 3, I'll want an open circle at 3. And then I'm going to shade to the left. Okay, here's another example. So what if I had the set of all numbers x such that x is a number that's greater than or equal to negative 7? Okay, so that's how I'd write that as a set. As an interval, then I'm heading out towards the positive direction, towards infinity. Okay, so I'm gonna write down negative 7 comma infinity, and this time I'm including negative 7. Okay, with this being a greater than or equal to situation, so I want a bracket by negative 7. Okay, parentheses by infinity. By the way, you'll never have a bracket by infinity. That doesn't make any sense, because the only reason to include a bracket by a number is if you're including the number. Infinity is not a number. Infinity is just a symbol that we use to indicate unboundedness in the positive direction. Okay, and negative infinity would be a symbol that we use to indicate unboundedness in the negative direction. Okay, so those will never have brackets by those symbols. Okay, and again, order matters, right? So smaller number first, bigger quantity second. Okay, as I read this from left to right. On the number line, here I am at negative 7. Now this time I'm going to include negative 7 because I've got a greater than or equal to situation. I'm including negative 7, so I want a closed circle at negative 7. And anything bigger than negative 7 means I'm heading out towards the right, towards infinity. Okay. By the way, for these problems, like, only graph on the number line if they're asking you to graph on the number line. And, you know, in some of these problems, like, they're not going to ask you to do anything with graphing, right? So there's no reason to do anything with the number line, or, you know, something like that. Okay. You don't want to be doing unnecessary stuff. Now, set notation and interval notation are very important, like I said. You want to make sure that you're reading the directions on My Math Lab, because on My Math Lab, they'll want you to or my open math they'll want you to write down an answer using interval notation or using set builder notation. Okay, and so you want to make sure you're using the correct notation there to give your answer. Okay, here's another example. What if we had the set containing the numbers x such that x is a number between -1 and 3, including 3. You're not including -1, but you're including 3. Well, as an interval, I'd write down -1 to 3 and have a bracket by 3 because I'm including 3. I'm not including -1, so I want to parentheses by the -1. And on the number line, here I am at -1, and then go over ways to the right and mark out 3. We want a closed circle at 3 because we're including 3. We want an open circle at -1 because we're not including -1. And anything between those two numbers is what we're describing in this group here. So I'd shade between the two circles on the number line. Okay, here's another example. What if I had the set of all numbers x such that x is a number that's less than -5 or x is bigger than 3/4? Okay. As an interval, anything less than -5 means I'm heading out towards negative infinity. I'll say negative infinity comma -5. I got parentheses on both ends, right, because I don't have a less than or equal to. Or anything bigger than 3/4 means I'm heading out towards infinity. And so I'd say 3/4 to infinity and parentheses at both ends there as well. Okay, now the union sign is a symbol that you can use if you're using interval notation to take place of the word or. Or is only 2 letters, so I'm gonna use or. Okay. But the union sign means the same thing. Okay. Now, if you have a set that contains the word or in it, it must contain the word or in your answer. Okay, like if I were to write this down, say x is less than -5, right? And also x is bigger than 3/4. Okay, so what would be the problem with writing it like this as a 3-part inequality? So I got a left part, a middle part, and a right part, or a compound inequality is sometimes what we say. If I were to write it like this, that wouldn't make any sense to anybody, because you're saying that -5 is bigger than 3/4. Is that true? -5 is bigger than 3/4? No. Okay, so something like this, we don't want to write that down. Okay, in other words, if the answer contains the word or, it must have the word or written. Otherwise, you're not writing down the correct answer. Okay. On the number line, okay, anything that's less than -5 means I'd shade to the left of -5. Anything that's bigger than 3/4 means I'd shade to the right of 3/4. I'm not including either one of these two values, so I'd have open circles there at those two spots. Okay. Here's another example. So what if I had the set of all numbers x such that x is not equal to -2? I'm describing every number, just not -2. Okay, so as an interval, anything that's less than -2 is okay. Also, anything that's bigger than -2, that's okay also. I'm just not using -2, right? So I'd want parentheses thereby at everywhere. I'd have parentheses at the -2 because I'm not including -2. Also, I got parentheses by infinity and negative infinity, right? Because those are not numbers. Okay. Here's the graph of the solution. So I'd mark out -2. I got an open circle at -2 because I'm not including -2. And I'd shade everywhere else except for -2. Here's another one. Okay, so what if I were going to describe the set of all real numbers? There's lots of different ways that I can write down that set. Using set notation, any number that's between infinity and negative infinity is okay. Okay. And by the way, now x is strictly less than infinity and strictly bigger than negative infinity. What if I were to have equal signs there? Less than or equal to? That wouldn't make any sense because infinity is not a number, right? So there's no reason to ever include infinity. By the way, if I had a less than or equal to sign by infinity, that would be like saying that there's a bracket at infinity. And I just said, that like up here when I was talking about that, when infinity is not a number, so you'll never have a bracket by the infinity sign or the negative infinity sign. Okay. Using interval notation, I have the interval negative infinity to infinity, parentheses at both ends, right? Now, I can also use a capital script R to represent the set of all real numbers. You'll see that on some of the problems. You can use that if you'd like. Or you can just write out in words all real numbers. That means the same thing. And here's what that looks like on the number line, right? I'm shading every single number on the number line. Okay. The basic functions worksheet. So we already looked at that in the last video that I showed you. So that was the one where you had these functions here. So these functions are not actually mentioned until this section, okay? But they had the graphs of the basics in section 1.1. They're not actually calling them by name though until section 1.2, right? So anyway, there's that worksheet again, okay? And tell you what, why don't we go ahead and stop right here in the notes, and we'll pick up with this example in the next video there, okay?